All right, I want to cover this example from practice problems for exam FM. I don't see a lot of actually good problems covered for annuities. We're really, well, so far really just annuities, but we'll see later on down the road. So hopefully I'll be able to come up with some good examples or just cover some good examples regarding the topic of financial mathematics. All right, here's the situation. We're making deposits every 4 years, so be careful here. The timeline here is every 4 years. So this is a 4 year, 1 4 year period, 2 4 year periods, right? This is not in year. That's why I have 4 years here, 4 year periods here. We're not given the interest rate. Okay, I'm making deposits of 100 every 4 years. We're not given the annual effective interest rate. And what I want to do is I want to let J actually be, I want J to be equal to the interest rate for a 4 year period. So the interest rate for a 4 year period. Okay, that's what I'm going to use actually. If you look at the solution, this is not what they do, but I usually match the interest rate to where the payments are made. So the payments are made every 4 years, so I want the interest rate to be sort of relative to the 4 year period. All right, what I need to do here actually is because they tell me something about the accumulated value of this annuity after 40 years. So that's why I have 10 here, because this is in 4 year periods. So after basically 10 deposits, right? This, by the way, because the first deposit is made immediately, this is what's called an annuity due. So I need to compute the accumulated value, AV. Okay, this is the accumulated value of the annuity due. So what are we going to do here? This is our deposits are 100. Okay, and I don't know how much detail I want to go into this. I want to just write it out. How do you? Let's just sort of, if you're new to the game, how do you do this sort of thing? I'm not going to write down the formula yet. I'm just going to write down intuitively what this is. I want to basically evaluate it right here. What I mean here is I want to find the value of these deposits at time 40, which is 10 4 year periods, right? That's why I have the arrow there. How do I compute that? Well, all of these need to go to this time, to time 10. Okay, and we have interest, which is unknown, but if we knew it, call it J, then what would this be equal to? Each of the deposits are 100, so what we're going to get here is we're going to get 1 plus J to the 1. That's this 100 going to year 10, year 40 I should say, and then plus 1 plus J squared plus dot 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 plus all the way to this one. Actually, so I'm sort of going backwards. I'm thinking of starting here, then here, then here, all the way to here. How many intervals are between here? There are going to be 10. So 1 plus J to the 10. All right. There's my accumulated value. Now it turns out this right here, this is, let me just write it out. Baby steps. This is the accumulated value of an annuity due, and it's only payment of $1, but I have $100 here. Let's just avoid technicalities. This is basically accumulated value of an annuity due. And we have a symbol for that. Okay, I'm not going to compute it this way, by the way. This is equal to 100. If I want the accumulated value, we use S. Okay, how many payments did we make? We made 10. Now I drew a little angle here. Since this is annuity due, I put 2 dots there. If it was annuity immediate, I would not have 2 dots. The interest rate I'm going to use is J. J is unknown. Right? J is the interest rate for 4 year periods. It is unknown because tell me nothing about the interest rate at all. Right? So there is my accumulated value for 40 years, aka 10 payments. Right? 10 payments. So this is the annuity due. Symbol for annuity due. Now, they also tell me that I need to compute the same, I need to compute the accumulated value for actually 20 years. So now I need to go to 5 here. To 5. So I need to add up basically find the value of these $500 taken, evaluated at time 5, which is really 20 years, right? So also we have that AV, and maybe over here I'll put, let me put 40 years, just to be clear here. AV 20 years. So what is the accumulated value of my deposits after 20 years, being deposited every 4-year period, is going to be 100. I could do this same argument. Okay, this looks like a finite geometric sum, by the way. But I mean, it's the same thing. We're just going to go to a power of 5. So it's going to be 100 times S double dot 5 angle J. All right. Now, look at the other information they gave me. They told me that after 40 years, the accumulated value is X. Actually, this is X, and X is what I want to find. So this is X. But X is equal to 5 times the accumulated value of the annuity due after 20 years. So we get an equation. So from the question, we have, so then we have the following. We have that 100, okay, S double dot 10 angle 10 J is equal to 5 times this. That's what they told me, right? 500 S double dot 5 angle J. All right, this looks good. And actually, if you look at the solution, to me it seems more complicated. So I'm going to show you how to do it this way. And I'm going to show you how to use the calculator as well, because that's quite important. All right, so now, how am I going to solve this? Because if you think about it, I don't know J. There's one equation, one unknown. I don't know J. So let me show you what I'm going to do. I'm going to use kind of a nifty formula that you should know actually for this exam. What I'm going to do is I'm going to divide by 100, and then I'm going to bring this quantity over here. So what I mean is this is equivalent to saying S double dot angle 10 J divided by S double dot angle 5J is equal to 5. Why on earth would I do this? Well, first of all, why on earth would I do it? Because I don't have any room. So damn it. Let me come up here. We don't really need our time diagram anymore. So let me come up top. All right. I'm just going to derive the formula actually from here that I was referring to. You should actually just know this after enough practice, but let me just show you what I mean. It's really easy, so I'm going to leave that there. If we want to compute x, right, our goal is to find x. So looking at this right here, just go back to the definition of accumulated value of annuity due. Okay. Let me maybe just start right here. So this says, again, I have S double dot angle 10 J divided by S double dot angle 5 J is equal to 5. The left-hand side actually simplifies to be something quite nice. So let me show you what I mean. Again, definition. This is just using the definition of an annuity due, accumulated value. Okay, up top, this is going to be the following. This is going to be 1 plus the interest rate. I'm using J to the 10 minus 1 divided by 1 plus J to the 5 minus 1 equals 5. Now you might be saying, well, what happened to the denominators of these two expressions, right? I mean, this is annuity due, so it's divided by the discount rate. This is divided by the discount rate as well, but those are the same discount rate, they cancel. Hopefully you're convinced. So now, what do I have? This is the difference of squares. This can be thought of as the difference of squares. This is 1 plus j to the 5th minus 1 times 1 plus j to the 5th plus 1. The minus 1 terms cancel, so what do I get? 1 plus j, to the 5th plus 1 is equal to 5, right? Now let's find the interest rate j, and we'll be pretty good. So now this tells me, let's get j by itself, so subtract 1, take the fifth root, etc. Right? This tells me that j is equal to 4 to the 1/5 minus 1. And this is approximately, I'm going to write it as a percent. This is approximately 31.95%. So in terms of interest rate, pretty high, but it is over a 4-year period. Keep that in mind. Now I'm pretty much done, actually. I'm pretty much done. I'm pretty much done. So, and I wasn't going to write this in general, but write this in general. I mean, if this is 2n and this is n, then it simplifies this expression on the left. This is just to the n power. There's also a formula regarding the present value as well. Maybe I'll make a video on that later on. Let me get back to the mission. The mission is to find this. I actually have everything I need because I have j. And I'm going to show you this in the calculator. So let's see. This is what we want. So hence, what we need to do is we need to compute 100 times s double dot angle 10, where the interest rate, j, over the 4-year period is 31.95%. This will be my x. Alright, let me show you how to do this on the calculator, because honestly I was very resistant to using this because I hate it. But when it comes to computing annuities, it's quite useful. Actually, I found some problems that if you don't know how to use this, it's pretty much impossible. Because sometimes you need to find the interest rate, and if you think about it, if you just think about how an annuity works with this geometric sum, the interest rate can be actually impossible to solve. It's some weird polynomial that's of a very high degree. I mean, it's just a nightmare. This thing actually is quite useful. Let me show you how to do it. On the BA2 plus, BA2 plus is what we're going to do. First thing you're going to do is set it equal to 4 decimal places. I've been advised to keep everything at 4 decimal places. You can do this by just by pressing second and then format, and you might have to scroll through, but here mine says decimal, and you just press 4 and enter. Alright, now second quit, so it's good there. Next thing is you want the payment. The payment actually you're going to leave as negative 100. This is my payment I'm making. Maybe it's a deposit, but we can think of it as a payment. There's a payment key, so in terms of the keys, this is what we're going to do. We're going to do 100, and then I'm going to press the plus minus key. Plus minus, okay? That takes care of the payment. Now I'm going to do n, and actually the order doesn't matter. So now I'm going to do 10, that's the number of payments I'm making, and then I'm going to do n, okay? Now I'm going to do the interest rate, okay? And that's, you actually put it in as a percentage. So you literally type it in as 31.95, and then you press the I over Y key. I over Y. The interest rate per year. Now this is interest rate per 4 years, but it doesn't matter as long as you have the number of payments done correctly. And then you press, after this you press compute, right, CPT. Now what am I looking for? I'm interested in the future value. So compute future value, and that gives me my answer. And the answer you should get here, when you round, is you should get that this is 6195. So that's my answer. Alright. That takes care of the problem. Tell me what you think. I am teaching myself all of this material. I've never taken a financial mathematics course. So if you have some suggestions about how to explain stuff, or just suggestions in general, I'm happy to hear them. I assure you that I will, get better at explaining. But hopefully this made sense, and hopefully this was useful. Again, I definitely advise you to get the BA2 Plus. You definitely need this. In the beginning you don't, but you do need it. I'm actually using both. It's the TI, the multi-view, and the BA2 Plus. I do some computations on either one. All this annuity stuff though, I do it on the BA2 Plus. I forgot to mention something that's extremely important for this question. You're not going to get the right answer if you do this. The reason is because the double dot. The double dot. And it actually took me a while to figure this out. something you have to do first. You have to make your calculator know that your payments are being made at the beginning. That's what the double dot does. So before you type this in, I need to do second begin, second enter, set, and then quit. So let me write that down. So the first thing you need to do, and of course you need to clear your time value of money. You need to do second future value, second clear time value. Always clear the time value of money. Okay, but to get it in begin mode, you need to put it in begin mode. So to do that, before this, you need to do second begin, BGN, okay? And you need to set it to that. So then you do second begin, and then second enter, okay? And then second, and then set. It says set there, and then second quit. So kind of annoying to do that, but second begin, second set, second quit. So you're setting your calculator, again, you're setting your calculator to be in begin mode, which means now your calculator knows you're making the payments at the beginning. Okay, it's because it's annuity due. It's not annuity immediate. Alright, hope that makes sense. Then do all this, and you're good to go. Alright.